Hello everyone, this is Vasant, a nine-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve a new problem on stresses on inclined sections. So this is the problem over here. A circular bar, a circular brass bar of diameter D is member AC. This is a truss ABC given. So means this is a pin support, this is a pin support, and this is a pin support. And load P is applied over here. That value is given by 30 kilonewton. Okay. So the allowable shear stresses in brass are 90 MPa in tension and 48 MPa in shear. On the braced joint, means this rod AC is made up of two rods and they are braced here. Okay. So on the braced joint, the allowable shear stress are 40 MPa in tension and 20 MPa in shear. So first of all, we need to think one thing. Suppose let us go here. In this case, suppose in rod, suppose sigma max is sigma. Then what tau max it should be? It will be sigma by 2, right? So suppose in the rod, if you take 90 MPa in tension, 90 MPa in tension. So if in the rod 90 MPa in tension is the maximum sigma, then what will be the shear? Shear will be 45 MPa, that is less than 48 MPa, then it will be safe. But if you take 48 MPa as the maximum shear in the rod, then what will be the maximum tension in the rod? That will be 48 into 2, right? 48 into 2 will be 96. It means it is greater than 90. So it will break, it will fail, right? So you should not consider 48 MPa. You should consider 90 MPa for calculations, right? And if we go here on the braced joint, the allowable stresses are 40 and in tension and 20 MPa in shear. So if you consider 40, the maximum shear stress will be 20. Yes, it is also 20, so it is safe. If you consider 20, it will be 40, so safe. So you can consider any one of these two, right? You can consider any one of these two, that will give you the same answer. So what we need to find out? What is the tensile force NAC in bar AC? What is the minimum required diameter D minimum of bar AC? So if you see that, if you consider joint C, so joint C pe NAC and NBC, this is 60 degrees and this is P, right? Apply sigma Fy is equals to 0 at this joint. So that will give us NAC sine 60 is equals to P, right? So NAC is equals to 2P divided by root 3. So what is the value of P? That is 30 kilonewton divided by root 3. Root 3 ka value 1.732. So if you calculate this, you will get 34.64 kilonewton. Okay. So NAC is equals to 34.64 kilonewton. So this is part A. So let us go to part B. So what is part B? What is the minimum required diameter D minimum of bar AC? So we need to find out D minimum. We need to find out D minimum of the bar AC. So see, in bar AC, is subjected to NAC and AC, right? So if you consider first case, this is first and this is second. So if you consider first one, so what is the sigma max in first one? In first one, sigma max will be is equals to sigma, that will be NAC divided by A, that should be less than 90 MPa, right? Do you agree? Yes. So what is A? A is pi by 4 D square. So NAC is 34.64 kilonewton divided by pi by 4 D square less than 90 MPa, right? let us calculate at 2. See, in 2, it is an inclined section, right? So for a inclined section, what is sigma max? Sigma at inclined section theta will be sigma x cos square theta, sigma x cos square theta, right? So what is theta? If you consider here, this is the cross section given, and this angle is given as 36 degrees. But our theta is, this is perpendicular cross section, this is cross section. Angle between these two cross sections, that is how much? 54 degrees, right? So we can write sigma theta is equals to 54 degrees is equals to sigma x cos square 54 degrees. So this will be NAC divided by A cos square 54 degrees. That should be less. That should be less than. That should be less than how much? 40 MPa, right? So if you NAC is 34.64 into 1000 newtons divided by pi by 4 d square into cos square 54 degree less than 40, right? So to consider d square greater than, that will be pi by 4 into 40, sorry, 34.64 into 1000 into cos square 54 divided by pi into 40 into 4. Okay, the value of uh, cos square 54 is 0.345491,503 as seen in the calculator. So this is the value of cos square 54. If we calculate the value of this, wait a minute, 34.64 into 1000 into cos square, that value is 0.345491,503. So divided by 40 divided by pi, that means 3.14 into 4, that is d square is greater than 381 mm. Okay, then d minimum in this case will be under root 381, that will be 19.5 mm, right? Let us go to this case. In this case, d square greater than 34.64 into 1000 into 4 divided by 90 into pi, right? Let us calculate this value. So 34.64 into 1000 into 4, okay, divided by 90 and divided by pi, 3.14. So this value we get as d square is greater than or equals to 490.3. Okay. So then d minimum will be equals to square root of 490. So that will be 22.13. Right. So we need 22.13 mm. This is mm for first case. For second case, we need d minimum as 19.5 mm. So see, we need to satisfy both cases. If you fail to satisfy any one of the cases, then the rod will fail, right? So if you take, values between 19.5 and 22 point, what is that value, 22.13, then rod will fail, because D minimum in this case to not fail is 22.13, but it will, the braced joint will be safe, but the rod will fail in the in tension, simple tension. It will not fail at braced joint, but it will fail at another section. So D minimum should be is equals to 22.13 mm. Okay. So with this we completed this problem. In next lecture we are going to solve another problem. Until then, take care. Bye bye from 9pointer. Thank you.